Imagine standing before a mirror that does not reflect your face, but instead reveals the memory of existence itself. Not a surface of glass, but a window into time where every flicker of light carries a story older than anything you have ever known. This mirror does not return the present. It gathers light that has traveled for billions of years across an ever-expanding universe, preserving moments that no longer exist except as motion through space. What you see is not who you are, but what once was. An ancient reality encoded in photons that began their journey long before Earth formed, before oceans existed, before life ever stirred. Each particle of light is a messenger carrying fragments of a past that has long since vanished. To observe the universe is not to witness it as it is, but as it was across countless layers of time. This is the true purpose of the James Webb Space Telescope. It is not merely a machine built to see farther into space. It is a gateway into time itself, designed to reveal the birth of structure, the ignition of the first stars, and the emergence of galaxies from a universe that once knew only darkness. For decades, scientists believed they understood this story. According to the Big Bang model, the universe began about 13.8 billion years ago in a state of extreme density and temperature. As space expanded, energy cooled and condensed into particles, forming hydrogen and helium. The young cosmos filled with vast clouds of gas. Then came the cosmic dark ages, a time when matter existed, but no stars had yet ignited. For millions of years, the universe was silent and invisible. Eventually, gravity began shaping that darkness. Tiny density fluctuations grew stronger. Gas collapsed inward, becoming hotter and denser. And within those collapsing clouds, the first stars ignited, massive, unstable stars that burned intensely and lived briefly, flooding the universe with light for the first time. From their formation came the earliest galaxies. According to long-standing theory, these galaxies should have been small, chaotic, and simple. The deeper we looked into space, and therefore back in time, the simpler the universe was expected to appear. But when the James Webb Space Telescope began observing the distant cosmos, that expectation began to unravel. Where earlier telescopes saw faint smudges, Webb revealed structure. Ancient galaxies appeared far more evolved than expected. Some showed rotating disks, luminous cores, even hints of spiral patterns, structures thought to require billions of years to develop. At first, scientists questioned the data. Distance in astronomy is measured using redshift, the stretching of light as the universe expands. Perhaps the galaxies were closer than they seemed. But observation after observation confirmed the same conclusion. These galaxies were real. And they existed astonishingly early, only a few 100 million years after the universe began. In cosmic terms, that is almost instantaneous. It is like discovering a fully developed city where only the earliest foundations should exist. The mystery deepened when scientists studied the chemistry of these ancient galaxies. By analyzing light, astronomers can detect the elements within distant objects. What they found was surprising: carbon, oxygen, nitrogen, even iron. These elements are forged inside stars and released during explosive stellar deaths. Generations of stars must live and die to produce them. Yet here they were, appearing far earlier than expected. This suggests the early universe may have been far more active than we imagined, a place where stars formed rapidly, lived brief and violent lives, and enriched space with heavy elements in a fraction of the predicted time. Even more puzzling was the discovery of supermassive black holes in the early universe. These enormous objects were thought to grow slowly over billions of years. Yet Webb has revealed black holes that already reached immense sizes surprisingly early. Scientists are now exploring new ideas. Perhaps some black holes formed directly from collapsing gas clouds, or perhaps unknown processes accelerated their growth. For now, the mystery remains. the shapes of early galaxies raise even more questions. Instead of chaos, many appear organized and structured. This suggests the laws of cosmic formation may be more efficient than we once believed. Dark matter, invisible yet detectable through gravity, may act as a hidden architect, guiding the formation of galaxies across the universe. And perhaps the most profound discovery lies in chemistry. Observations have revealed complex carbon-based molecules drifting through ancient interstellar space. These are the building blocks of life, detected in regions whose light has traveled billions of years to reach us. This means the ingredients for life existed long before Earth formed. The implications are staggering. The deeper we look, the more the universe defies expectation. Instead of a slow progression from chaos to order, we see rapid formation, early complexity, and galaxies evolving far sooner than predicted. The instrument built to confirm our understanding is now reshaping it. Every photon captured today began its journey billions of years ago, carrying fragments of a story that existed long before Earth, long before life, long before any observer could question it. Now, after crossing unimaginable distances, those signals arrive here, whispering pieces of a narrative we are only beginning to understand. We built a machine to see deeper into space than ever before. But in doing so, we uncovered something far more profound. The deeper we look, the less certain everything becomes. And somewhere within that ancient light, the true story of the universe